Okay. Now that we've finished up complex operations, adding, subtracting, multiplying, dividing, absolute value, graphing complex numbers, the last half of this unit focuses on properties of exponents and radical operations. So I have some notes here on properties of exponents for us to review most of this with. I think a lot of you have seen this before, but it's good to go back and refresh. Maybe there's a couple of things up here that are less familiar to you. So we'll start with this. Properties of exponents. When I multiply exponents, x to the nth times x to the n, I add their powers together. X to the nth times x to the n is x to the m plus n. So for example, x squared times x to the fifth is x to the seventh, because there are 7 total x's being multiplied together. 2 from the x squared, 5 from the x to the fifth, so all told, that's 7 x's multiplied together, 4 more x to the seventh.
So is it not x to the n?
That's down low on number 3. We'll come to that in a second. I have this many x's multiplying, I have this many x's multiplying, so altogether it's the sum of the 2 in total. Does that make sense? Okay. Now on row 2, rather than multiplying exponents, now we're dividing them. X to the nth divided by x to the n. Rather than adding those exponents together, I subtract. X to the nth divided by x to the n is x to the m minus n. I just do the opposite. Multiplying, I add the exponents, so when I divide exponents, I subtract. X to the fifth divided by x squared. Well, that's 5x's being multiplied on top. I can divide out, take away, get rid of x squared of them, get rid of 2 of them. So how many are left over? X to the third. X to the fifth divided by x squared. 2 of them cancel out, leaving x to the third left over. On row 3, I have 2 of power. X to the mth raised to the n. X to the mth power raised to a second power. When I have power to a power, I multiply those 2 values together. X to the mth to the nth is x to the m times n. So x squared to the fifth. That's x squared times itself 5 different times. X squared times x squared times x squared times x squared. 5 total times. So it's x squared 5 times for how many x's? 10. 2 5 times is 10 total x's multiplied together, or x to the 10. 2 times 5 makes 10. Yeah, Justin?
I'm confused on the first one. Like, say x is 2.
X squared is x times x. There's 2 x's multiplied in x squared, right?
But like 2 squared plus 2 to the third.
Yeah, you can't add those together. There's a difference between 2 squared times 2 to the third and 2 squared plus 2 to the third.
Oh, never mind.
Row 4 is a couple of different specific powers to keep in mind. Anything to the first power is equal to itself. X to the first is equal to x. I don't usually write the first power because it's kind of understood. We don't say 3 to the first, we just say 3. The 0th power, anything to the 0th power, is just equal to 1. Anything to the 0th power is always 1. Last 2, maybe a little bit less familiar, I think. We have negative exponents and rational exponents to look at in these bottom 2 rows. X to the negative nth. The exponent has a negative sign. X is being raised to a negative power. I cannot have a negative exponent in my simplified final answer. I have to make it back into a positive exponent by using what I kind of call the upstairs downstairs rule. If it's a negative exponent, I make it back into a positive exponent by putting it back down in the denominator, back downstairs. X to the negative m becomes a positive exponent when I write it as 1 over x to the m. So x to the negative fifth would be 1 over x to the positive fifth. I make it back into a positive exponent by shifting it back down into the denominator. On line 6, we have the conversion back and forth between radicals and rational exponents. How do I write roots as exponents? The nth root of x to the mth power is written as an exponent as x to the m over n, a fractional exponent. The exponent is a fraction. Do that. The index of the radical, this number next to the radical, its index becomes the denominator when I write it as an exponent. The nth root of x to the mth power is x to the m over n. So for example, what is the square root of x to the fifth? As an exponent.
5. X.
There's really a 2 right there as the index of the radical because it's a square root. There's really a 2 right there because it's the index of the radical as a square root. Is that x to the 2/5 or x to the 5/2? 5 over 2, 5/2, x to the 5/2. The index of the root becomes the denominator of the radical. How about x to the 3/4? What would that be as a radical? Is it the 3rd root or the 4th root?
The 4th root of x.
You bet. You can go back and forth between different exponential notation and make it into radicals, or vice versa, take a radical and write it in exponential notation.
Where's the numbers coming from?
Like these numbers in blue, I just made them up as a specific example. Here's the general rule. Here's just kind of like a quick example to show it to you in action. All right, let's get some practice here. Could you guys grab your laptops and get onto your Gmail while I practice that? Here's pretty much the rest of the semester. Only 5 weeks left.
Yeah.
Looks like you remember out of power, but wait a minute, it's 100%.
Yeah.
All right. Get on your email. I just gave you some practice, and I linked the solution keys in your email. Right here. We've got 6 different links for the 6 pages in this handout. Let's just pull up the first one, properties of exponents. We're going to do some review on simplifying exponents with some of those different rules from the back wall here on this practice handout. Let's try a couple together. I'll leave you guys the rest of class time to do some work on your own. I'm going to slide through here. Pardon me. There we go. Thanks, guys. You guys online, were you able to find that in your email? I know I don't have the physical copy for you here at school, but can you pull it up on your own laptops?
Yeah.
Everyone got it? See it okay? Excellent. Yep. We're just going to do some practice on these right now if you want to do it on your own scratch paper and follow along with us.
You have to list them out, right?
Usually it doesn't matter because multiplication order doesn't matter. How about we try number 3? I got the answers here in red. Let's see if we can find how this works. Number 3, 4r to the negative third times 2r squared. Multiply. What's 4 times 2? Now do the exponents. What's r to the negative third times r to the second? What do you do with the 2 powers? We add, subtract, multiply, divide? Add them. What's negative 3 plus 2? So this is r to the negative first power. But if you look on top, it says directions. Simplify. Your answer should contain only positive exponents. Like I said, I cannot have negative exponents in the simplified final answer. So I have to make this back into a positive exponent by using this upstairs, downstairs, line number 5 rule. A negative exponent becomes a positive exponent again when I write it as a fraction, put it on bottom. So r to the negative first is really 1 over r to the first, or just r. Don't move the 8. 8's not the negative exponent. 8 doesn't have a negative exponent. Only move the r, because it has the negative exponent. So final answer, what's 8 times 1 over r?
8 over r.
Done. Multiply the constants. 4 times 2 is 8. Multiply the exponents. It gave me r to the negative first. We'll move it back down to the bottom to make it into a positive exponent. All done and done.
What time does 5th hour start?
5th hour starts right when 4th hour ends, so probably about 11 o'clock. How about number 10? I'm just going to kind of skip around and try a couple that I had in mind as good examples. X squared y to the negative fourth times, I don't know, how about x cubed y squared? Same concept. Multiply exponents. What do I do to the powers? I got to add them. When I multiply exponents, add them together. So what's x squared times x to the third? Okay, got that put together. Do the same thing with the y's. Y to the negative fourth times y to the second is y to the negative 2, because negative 4 plus 2 is negative 2. Are we done? No, why not? So what's my final answer going to be?
X to the 5th over y squared.
Over y squared. Don't change the x. X is fine. It doesn't have the negative exponent. The y does. So this is x to the 5th times 1 over y squared, or simply just x to the 5th divided by y to the second.
Take 14, for example, with 4a cubed, and then that.
Yeah, so you have to square both 4 and a to the third. Take 4a to the third times 4a to the third. I was going to do one similar to that here in this next one. How about number 12? Let's try 12. Very similar, but with a negative exponent. 2x squared to the negative fourth. Quantity 2x squared to the negative fourth power. Right away, I notice what? Negative power. So Taya says it's got a negative power. How do I make that back into a positive exponent? Positive power. Move to the bottom. What do I have to move to the bottom? What is being raised to the negative fourth power? The whole thing, right? So to make this back into a positive exponent, don't I have to move the whole thing back down to the bottom? So this is the same as 1 over quantity 2x squared, but to the positive fourth power now. Write it as a fraction and move it to the bottom to make that negative 4 exponent back into positives. Now I need 2x squared to the fourth. Everything in this quantity needs to get raised to the fourth power. So let's first do 2 to the fourth. What is 2 to the fourth? 2 times 2 times 2 times 2? 16. Not 2 times 4, it's 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. Now how about x squared to the fourth? That's power to power. What is x squared to the fourth?
X to the 8.
Good. 2 times 4 makes 8. X squared times x squared times x squared times x squared. That's 8 x's all multiplied together. Yeah, trust.
when we bring like 1 over 2x squared to the negative fourth, shouldn't we change the sign of the squared too?
Say, for example, this is 2 to the negative fourth, and x squared to the negative fourth, that's x to the negative eighth.
So it should be
1 over x to the eighth again.
Yeah.
If you want to do the negative exponent first, and then move both of those back down to the bottom, you can.
okay.
By moving this back down to the bottom first, I'm only going to change that 4 exponent back into positives now, okay? Let's try one to the back. Let's flip over to the back. How about 25? Let's do that and we'll call it a day. You guys can finish up the rest of these. Working on your own. You said 20. Let's do 25. We can do 26. Do you want to do that?
No, I'm just asking.
Let's just do 25. 3m to the negative fourth divided by m to the third. When I divide exponents, what do I do to the powers? Subtract. So what is m to the negative fourth divided by m to the third? Because negative 4 minus 3, be careful, negative 4 minus 3 is negative 7. So let's write this as 3 times m to the negative 7, because negative 4 minus 3 is negative 7. When I divide exponents, subtract powers. Negative exponent, so where's that going to go?
Bottom.
3 over m to the positive 7. I'm only moving the m because m has the negative exponent, not the 3. Why don't you guys take the rest of class and do some more practice here on this first couple pages.